Write down the nth term of the sequence a sub n suggested by the pattern. So this first pattern here is 1, 2/3, 4/9, 8/27, and 16/81, and so on. So this pattern does keep going. So that's what the 3 dots signifies. So what we want to do here is we want to determine what is the a sub n1 here. So can I generalize what I am seeing as these terms change? So what we can do here is we just take a look at saying, okay, what's really going on? So if I can see what's going on from here to here, that's more difficult to see. 1 to 2/3. Well, not really. It looks like I can times it by 2/3 and then take 2/3 to get 4/9. I could also times that by 2/3. So it looks like I'm timesing each one by 2/3, and hopefully you can see that as well. Because honestly, this is where the creativity comes in when we're dealing with these sequences. And they really stopped them at 5th grade, which was a terrible idea. So 2/3 because they're in everything. And then 2/3. So each one I'm timesing by 2/3. So let me ask you this question. Do you know what is repeated multiplication? Hopefully you thought of exponents, because exponents are repeated multiplication. And each time I'm multiplying by 2/3. So I would think that my sequence is going to look something like 2/3 to the n. Now again, I may not be completely correct here. I may have to adjust it some, but I'll have to play around with some numbers to understand it. So let's take a look at A1. So then A1 would be, that means I would put a 1 there, and it would be 2/3. And my first term is not 2/3. So that means I'll have to adjust this a little, because what I'm going to want here is anything to the 0 power is 1. So if I did a 2/3 to the -1, and now when I put my 1 there, I'm going to get 1 minus 1, which is 0. So again, I can adjust this any way I choose. I'm creating this formula. And that's what I'm doing here. And in essence, what I'm doing is I'm creating an explicit formula for this. So now let me look at my A1. So then A1 is going to be 2/3 to the 0 power, which is 1. So I get my first term here. Now again, I have to continue this pattern to really convince myself if this is what is going on. So 2/3 to the first, I should say 2 minus 1. And that's going to be 2 to the first, which is 2/3. And then a 3 equals 2/3 to the 3 minus 1. Now remember, these indices here are what I'm going to put in place of every n. And that's going to be 2. So that would be 2/3 squared, which is 4/9. And we can see that this is actually working. So I would say then that this here is my nth term. And I could actually write it as a sequence. And that's the nice thing about this too. That's why we're doing this. That's why we're trying to find that a sub n term. So we can actually find the sequence of this list of numbers, which is also a sequence, but we're finding the explicit formula of this sequence. Okay, so let's take a look at the next one now. This one says 2, -4, 6, -8, 10. The first thing I'm going to deal with here is not the negative and positive, because it's what we call an alternating sequence. What we're going to look at here, though, is we're going to look at just the numbers themselves to try to create that pattern first. We'll deal with the negatives in a moment. So we're going to treat it as two different characteristics and address them individually. Okay, so the first thing is 2, 4, 6, 8. So when I see this pattern here, they're all 2 apart. So in essence, what I'm doing, if I'm just looking at the numbers, not the signs, it'd be like I'm adding 2 every time. And when I think of repeated addition, I think of multiplication. And what am I multiplying? 2. So think of this like a slope. So 2n. So would I be increasing 2 every time? So when I put in a 1 there, that would be 2. When I put a 2 there, that would be 4. When I put a 3 there, that would be 6. Do you see what's happening here? It's creating that pattern. Okay, so actually that worked out great because that 2n is actually what works for this pattern for these numbers. At least for the numbers, not the sign. Okay, now the way we can address a sign here is we can use a -1 to some power. Now again, this power may not be correct. We might have to work this power out, but just in that similar fashion, we're just going to plug it in and see what works. So for A1, that's going to be -1 to the 1 times 2 times 1. So then this is going to give me a negative because -1 to the first power is negative. -1 times 2 is -2 times 1 is -2. And we didn't need a negative on the first one. We actually needed a negative on the second one. So I can just say n plus 1 and minus 1. It doesn't matter which way I go with this. But realize it's multiplication that I have here. So this here then is going to work for us. And we'll see that in a minute. So let's get rid of this and try it again. And that's what part of this comes down to. This is partially trial and error. So then that's going to be -1 to the 1 plus 1 times 2 times 1. So this then, whoa, why did I put a 2 there? Weird. 1 plus 1. I said 1 plus 1, 2. Okay, so that's going to be -1 to the 2. So when I square a negative, that means a negative times a negative is positive. And that's going to be 2. So this is actually going to be a positive 2. Now let's try A2. Again, it's good to try a few just to make sure. So -1 times, to the 2 plus 1, 2 times 2. And that equals, that's going to be an odd number of negatives, so I'm going to get a negative back. And then 2 times 2 is 4. So I'm going to get my -4. And you can see if I continue this pattern that this would actually be that A sub n. So in later videos, we'll show how to work with both of these sequences and show you how we can find formulas to help us with that. But for the most part, there's a lot of creativity here that we can use or tap into to get these answers.